This video is about using a sum or a difference identity. In this case, it's a difference identity because they're asking us to find the sign of x minus y. This problem is number 42 from section 4.3 of the Barnett-Trigg book, the 11th edition. So what they tell us is find the sign of the angle x minus y, given that the sign of x is equal to negative 2 over 5, and it's in quadrant 4, and the sign of y is equal to 2 over 3, and it's in quadrant 1. I'm going to start with the given information to see what I can figure out here. So the sign of x is in quadrant 4. I'm going to draw a reference angle in quadrant 4, and I'm going to call it x. It told me that the sign of x is equal to negative 2 over 5. Sine is opposite over hypotenuse, opposite over hypotenuse. One of these has to be a negative for this to become a negative quantity, and the hypotenuse is never negative. So the sign, or the opposite value, will be negative, and that makes sense because it's in quadrant 4 and y is negative there. I can use Pythagorean Theorem to solve for this quantity right here. I'm going to say a squared plus negative 2 squared is equal to 5 squared. A squared plus 4 is equal to 25. A squared is equal to 21. A is equal to plus or minus the square root of 21, but I know it's in quadrant 4, so I know it's positive. This is the square root of 21. This is everything I need to know about angle x. Angle y is in quadrant 1, so I'm going to draw a reference angle in quadrant 1. I'm going to label it y. It tells me the sine of y is equal to 2/3. Sine is opposite over hypotenuse. Everybody's positive in quadrant 1, so I know that I can solve for this value using the Pythagorean Theorem again. So I'm going to say a squared plus 2 squared is equal to 3 squared. A squared is equal to plus 4 is equal to 9. A squared is equal to 9 minus 4, which is 5. A is equal to plus or minus the square root of 5, but I know it's going to be positive because I'm looking at quadrant 1, and the cosine, or the x value, is positive in quadrant 1. This is everything I need to know about angle y. Now I'm going to look at the formulas for the difference formulas. The sign of x minus y is defined to be by this identity, and this is where I'm looking right here, the difference identities. The sign of x minus y is sine x cosine y, sine x cosine y minus the cosine of x sine y. All right, I just make sure I wrote that down right. Sine x cosine y minus cosine x sine y. Okay, we're ready to go. Now we're going to go over here and say, well, what is the sine x defined to be? Here is my angle x. Sine is opposite over hypotenuse, negative 2/5, negative 2 over 5. The cosine of y, right here is y, is adjacent over hypotenuse, or the square root of 5 over 3. Minus, by formula, the cosine of y times the sine of y. The cosine of x, the cosine of x is adjacent over hypotenuse, the square root of 21 over 5. The sine of y is opposite over hypotenuse, 2 over 3. Now, I'm just going to double check that I put things in the way I meant to. The sine of x right here is opposite over hypotenuse, negative 2/5. Okay. The cosine of x, I'm going to look at this guy right now while I'm looking at x, is adjacent, square root of 21 over 5. I like that. The cosine of y right here is adjacent over hypotenuse. Yep. And the sine of y is opposite over hypotenuse. Okay, that's fine. Now I'm just going to multiply fractions. Multiply the numerators together. Negative 2 times the square root of... Okay, let me start over. Negative 2 times the square root of 5 over 5 times 3 is 15. Minus 2 times the square root of 21 over 5 times 3 is 15. You could write this as one fraction or leave it like that. This is negative 2 square root of 5 minus 2 square root of 21 all over 15. This is as best as we can do because these are not like radicals and they won't combine.